point number 3. Multi-threading. Java solved that for us. Easy. One word you add in front of the method. That word is synchronized. And therefore, this will cater for multi-threading application. What does that mean? If there is 2 people trying to get that instance, or 2 people using that instance at the same time, changes to that instance will not, will cater for multi-threading, or will cater for solving the race conditioning problem. Will not allow variables to be updated within that instance without looking at who's holding that instance. Because it's the same variable now. So without making sure we don't lose the data. Okay? Great. So that is synchronized, solve the multi-threading. What's left? One thing left at the end. Within the object class, there's a class called object. It is important. If you are a Java developer, it is very important for every one of us to go to that object class, which every single class by default inherit that object class, and to see its content, what's inside. We're gonna relook at this again also in distributed programming. Okay, but at this moment, within the object class, the super class, which every Java class inherited, there is a method called clone, which allow you to clone an object into another object. If I don't override that, people will be able, instead of creating a new instance, they will be able to say x.clone, and they just copy that. Okay, I don't want that to happen. So what I've done, I've override that method. If somebody comes and call it within this class, I am throwing an exception. Because it's not inside this class, but it's in the super class, the object class. So therefore, by default, I am inheriting that clone method. So I'll need to override it to prevent that problem to happen. That's 4 points inside. Number 1, again, private constructor. A method responsible for maintaining one single soul instance, catering for multi-threading, override the clone method. After that, here we go. You put whatever variables you want, and then you start using them. You start using that instance in the system. This is a nice idea because we will need it again and again in many different systems. Maybe the simplest way to get your idea, your head around, is the connection pool. It is now part of many different packages anyway, but we used to write it our own, and many companies now still maintain their own connection pool. Anyone knows what a connection pool is for a web application?
It's like a limited number of connections that you just get one.
To the database.
Yeah.
Okay. Why connection pool is important?
Might not just be one database. Might not just be one database. So
Might be more. Nice. I like that one. We didn't used to get that answer in the past, but yes, we might have more than one database my web application is talking to. If it's replicated, one server is down, I look up the other one. Or if this is part of the data is here and another part is here, I look at this rather than that. But the initial idea of the connection pool started with something else. Started that databases have got a limited number of connections. They are not infinite like web servers. They just go down when they are overloaded. They've got infinite? Finite. They've got a limited number. Let's choose another word. A limited number rather than confusion. They've got a limited number of connections. So for example, database servers like Oracle I set up before, they've got 10,000 connections at the same time I'm talking. So people could query that database 10,000 times at the same moment, not more. So let's imagine a large web server for the NCC just in front of us, and that is using a database server. If there is 10,001 people at the same time, at the same site, clicking enter to the search, or clicking enter to enter the data. Therefore, the database server can't handle this traffic at the same time, 10,001 connection. Therefore, the database server will go to shutdown mode. Will not turn off, but it will stop receiving any more traffic. It will be overloaded. That is very important thing to manage. And that is singleton, clearly. Because that class is standing between all of those users. Okay? And all of those users are going in and out, querying the database, and you need to manage that. Another way of doing that as well, because if somebody is opening his browser, and he's gone for a coffee, you need to maintain the connection while many 500 people waiting to query the database. You can turn on and off, you can take that connection out of him and give it to somebody else. And at the same time, there is another big challenge in the connections to databases. To make a connection to the database, it is costly. You go to the database server and come back, and the database server gives you that connection to that Java application. Okay, therefore, it takes time as well. And to reduce the time, you create all of those instances and put them in the pool. Then the pool gives you one. And keep track of yours. Because if you're not using it, then he can just release it and give it to somebody else. Because we've got limited number. The same with replication with different servers. This is because we've got huge networks like Facebook, LinkedIn, etc. Many people using it at the same time. They thought, do I need to bring them to America each time? I can have a replicated database in UK for UK customers. Replication. So they just the same copy of the data of that database is in the UK, is in the States, is Sweden, etc. Therefore, you get the result faster and at the same time less cost, less time to get the data. Okay, so that is a good idea. So singleton connection pool is a singleton. And there is history class, static class, many other examples. And people coming back, how do I derive that? Only 4 points. Okay, that is the idea there. Don't want to go longer. So we thought we've talked enough about design patterns. It's not enough, believe me, but we have tried in 3 weeks to present some examples with their technical material as well, with the labs. You can still go and read more and practice more. I think it's a great area to improve yourself in. So before we leave, I think it's important to highlight anti-design patterns, bad ideas, so you can avoid as well, rather than just look at the best ideas. And refactoring. So what does these means? Usually a pattern is a good idea, an anti-pattern is bad idea to avoid, and refactoring better ideas. We try to improve. Okay? I'll talk about these 3 areas. So there is anti-patterns in many different areas of software development. There is software in the software development, in the software architecture, and even in the software project management. I'll talk about the first 2 categories. I'll present, there is many of them as well, not just as design patterns, as anti-design patterns. There is many well-known bad programmers doing bad stuff out there, and we need to avoid it. So I've just picked 2, the most common and the funniest. Number 1 is called control freak. A developer with a control freak attitude, where he's got a very large object, which all the control inside, very large class, that access simple data classes. It's got many other simple data classes inside. That class is growing in size. It's got so many methods to do lots of things. It's like somebody imagining a God class, which can do lots of things if he's there. Okay? So essentially, maybe a procedural design was used rather than object-oriented. A very long class which do lots of things. That is a very bad idea. Try to avoid it. Consequences for that bad idea is difficult to modify. Not based on a domain model. He is just touching every single domain he knows. It's difficult to test and difficult to reuse. Okay? So don't end up in that control. You have to have, if I were to think of creating a class, I'll think of its uniqueness first. A unique class, which could represent itself as one logical entity there, with its attributes and behavior. And that's it. Not much really needed. Then you could reuse it, you could get an instance of it, you could make it bigger, etc. The other bad anti-design pattern within the software development group is old baggage. So it's like developing a system with many classes whose purpose is not known. We call this a lava flow, a dead code, like my PhD code. And the examiner came in, looked at this huge number of classes, might be 600-700 classes, only a third of them work. The rest is lying there, is doing nothing, it's not in the project anyway. So that is, we call it lava flow or dead code. It's like much of this code is from a previous version you used to write and it's still there, you didn't take it out. And that is a very bad idea. You need to clean it again and again and again. We call this refactoring. You will need to keep refactoring this. And that is something you can talk about in your project later on. Because you can say it's a concise piece. You present yourself as a technical product. Unique, concise document. Not just in writing, but in writing also code. It will be very difficult to maintain. And it's going to get worse and worse and worse. Because obviously, the code is there. It's not used anyway in your project. Okay. Now it comes to the architecture side. Bad ideas in architecture. First is cover your asset, and the other one you know it already. I did it my way. Cover your asset is very bad idea in software development team.